Okay, good afternoon, everyone. So welcome back to the class. So I believe most of you already got the test result that I have put inside the Google Classroom. So, okay, before we start, let me ask you one question first. So let's say if we are doing this integration, okay? So how are we going to solve this? So this one is 4 minus 2 squared divided by 2 or 4 squared divided by 2 minus 2 squared divided by 2. Okay, let me turn off my WhatsApp first. So this is a A, this is a B. So which one is the correct one? So some of you say B, 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 B. Okay, let me create a poll and ask. Okay, which one? A and B. Launch it. Okay, 3 of you say B, 4 say B. Mm-hmm. 16 say B. Anyone of you say A? Okay, there are still 12 of you still haven't chosen. 18. What about the rest? 19. So we have 27 people here. So there are about a few of you still haven't do it. Okay, one of you say A. The remaining one. Okay, there are still few of you. I think maybe 2 or 3 of you still haven't chosen. Okay, so I believe majority of you will choose B. Okay, but back to the test question that I have shown you earlier. Some of you made a mistake in the integration part. I won't say some of you, I think most of you, if not mistaken. Okay, especially when you are looking for the number of the state. Okay, the part for the question 1 has this one. Okay, so this is our answer scheme. So many of you doing this part wrongly. Okay, some of you just directly use 5 minus 1 equals to 4 kT 3 to the power of 2. I think many of you did this wrongly. So if you are doing in this way, so which is a wrong one, this one is wrong, this one is wrong. But somehow you will still able to get the marks for the formula written here. Okay. So that's why some of you make this part wrong. And then some of you also do the same error here, take this part wrongly. Okay. So that's why you can see that your score are, some of you maybe a score you didn't do well in that because you do it wrongly. Okay. Then the third one, still acceptable. This thing is just a normal calculating the mid-gap one. So let's get back to question 1A. So all your P and Q, because each of you have a different P and Q value. So I will use the Python to directly calculate all the answers all together. Some of you do very well, like Ng Han Xiang, I think he get full marks, if not mistaken. Okay, 40 or 40. And then, but some of you didn't do well. So work harder next time. So let's see. So this one, question 1. Consider the unknown semiconductor potential state If I do math, this thing is given, this thing is given. And then at T equal to 400K. So determine the number of the quantum state between this one and this one. So as I showed you just now, the answer is like that. If you want to know that which slide is talking about this, you may refer to the slide 3. Okay. Wait a moment. Okay, no, slide 3. Okay, yeah, this one. This is the part where you know how to do it. Okay. For some of you, maybe you somehow separate this EV and E, but I will still give you marks, just deduct 1 mark from it only. Okay. Okay, so this is the way that we do the question 1A and 1B. Then question 1C. Okay. When you do the question 1C, this one is to calculate the mid gap. So in order for you to calculate the mid gap, you are going to use this formula. Okay, EFI minus E mid gap equals to Q over 4 KT ln MP asterisk over MN asterisk. Okay, common mistake made is in between here. Okay, so if you are doing this, you need to use 0.0259 multiplied by 40, 400 over 300. Okay, because in the question, the temperature is in the 400K. Okay, this is a small little trap only. And then the last part. I think the last part, majority of you can do it correctly, but some of you may calculate wrongly. I think it's just a careless mistake. So in order for you to do the question 4, okay, you can see the question is asking that the energy level will not contain any electron at T equals to 400K. Then find the respective energy level. Then this one is the percentage will be equals to 1 minus 1 plus exponential E minus EFI over KT. Then this thing, 0.5p. So if your p is 2, which means this one is a 1%. If 1% means 0.01, then you put here. Then this one KT also the same. You either use a 8.62 times 10 to the power negative 5 multiplied by 400. Or you use 0.0259 multiply 400 over 300. Either way also can, no problem. Okay, this is how we do the question 1. Any question on the question 1? Okay, question 2. Let's see the question 2. Question 2 is tricky a bit. Okay, where's my formula? Okay, this one, answer scheme. Okay, question 2. You will ask to find the conduction band energy EC with respect to the energy level, Fermi energy level. This one is a EC minus EF over KT exponential, then NC will be equals to the NO. Then you need to make the assumption that this will become the ND. Okay? And then you try to restructure everything. ND over NC equals to the exponential minus EC minus EF over KT. And then continue to do it. NC and D ln. So this one I move here. Move here, then this one is multiplied by KT. You get the Fermi energy level. Okay. With this formula, you are going to have a 2 marks. Okay. So that's why you can see that even if you calculate the answer wrongly, you are still able to get the full mark as long as you write the formula only. And then the next one. So EC and EF. Okay, we don't know that. We need to calculate this. KT 500. Okay, given the 500. So you need to consider the 500 degree. Okay. And then ln. The important thing is the NC. We don't know how to calculate the NC. but we are given some of the hint given here. Okay, and this is given, no worry. Then we need to calculate the NC. 2 pi mkt over h cube 3 over 2 h squared, I think. Okay, here's the thing. H cube, not h squared, sorry. H cube. Okay, I think it's h squared. This one is, I just write wrong here. No worry about it. H squared. Okay, here's the thing. Whenever when you are doing this, the common mistake is in the KT part. Some of you just rightly use the 0.0259 multiplied by, let's say the n is a 500 over 300. This thing is not doing it this way. Because when you are doing this, you cannot calculate in the EV form. You must calculate in the Joule form. So for the K, you need to refer back to the constant list that I have shown you earlier, which is in the lecture, this thing in the beginning of the lecture. Okay, lecture 2 or lecture 3 if I'm not mistaken. Okay, let me open back my lecture 2. Okay, your K, you must use a 1.38 times 10 to the power negative 23. And then your T, this one is a 1.38 times the following. T must put the 500. Okay, so H squared, you can refer to the constant list. And then the H squared is this one. This one, 6.625 times 10 to the power negative 34. Okay, so when you put inside the thing there, this value will be in the meter. You need to convert back to the centimeter. Then you only put back into here. Okay, to get your final answer. But in my marking style, if you get this thing formula, 2 marks. Another formula here, also 2 marks. Okay, so this is how we calculate it for the question A, 2A. Question 2B also the same. Right now calculating the MV. MV we use the same formula, just that M is changing only. But for the MV, this part will give you the 4 marks. Okay, answer 2 marks. And then the last part, where's my question? C. Determine the concentration of the acceptor impurity that must be added to turn the semiconductor into a P-type semiconductor if the Fermi energy level is 0.002 above the valence band. Okay, this one very simple and very direct. So this formula, if you written there, 2 marks. Even if you didn't write this, okay, if you didn't replace anything inside there, I also give you 2 marks. The following is a working step. Okay, 5 marks. Then your answer 1 mark. Okay, so concluding everything, you are going to have a 40 marks from here. Some of you making many careless mistakes, especially during the integration part and also this NC part. Okay, so but I think most of you can pass. A few of you maybe less than 20 marks, less than half. So no worry, try to work hard in your assignment. Okay. Any question so far? You can see if there is any adding problem or mass calculation wrongly in your script that I already posted to you. No worry, all your answer script, you can only see it on your own one. Okay, if you have any problem, please come to me. Q2C, this one. This one. So this one, I give you 2 marks. Then the remaining, you just need to replace the value inside there only. Okay. Okay, any more question? If no question, then let's discuss about the tutorial question. Have we finished discussing the tutorial question? In the manual tutorial. This one. Okay, let me turn on first. This one, have we discussed everything already here? This part, tutorial 3. Yes or no? Oh, okay. So I believe you already finished all the question. So we discuss the answer right now. Okay. Okay. By the way, before I forgot, we still have some replacement class to be made. Okay. So I think I take leave during that day, so that's why we don't have any lecture class for 2 hours, and the 1 hour for the tutorial class for the week 1. So for the 2 hour lecture class, when can we do the replacement? Which day do you suggest? Anyone? Or Yong Xie, are you here?
Yes, sir.
Okay, which day do you guys prefer to do the replacement class for this 2 hour?
Maybe later I send the available time for both group to sir.
Okay, sure, no problem. You send me later.
Okay.
Okay, so let's get back to the tutorial class, the discussion here. Okay, I believe most of you have already done everything. Okay, let me readjust this thing. Okay, consider a homogeneous gallium arsenide semiconductor. You want your ND 1 times 10 to the power 16 and A 0. Calculate the thermal equilibrium NO and PO. So in this case, we know that ND is more than NA. So NO is the major. This one is the minor. So to calculate this, we're using this ND minus NA divided by 2 square plus square root ND minus NA divided by 2 square plus NI square. MPO, you use the NI square divided by NO equals to the PO. Okay, so who can tell me the answer for the first question, 1A? Wong Gasing, are you here? What's the question for the 1A? NO and the PO. NO 1 times 10 to the power 16 cm minus cube. PO 3.24 times 10 to the power negative 4 cm minus cube. Okay, do you get the same answer as your friend Wong Gasing? Tan Xuping, what do you get? Tan Xuping, are you here? Do you get the same answer as your friend for the question 1A in the tutorial 3? For NO same, for PO, PO tak sama. PO you get 8030x6.42. Okay, so let's see this. So since this one is a gallium arsenide, we know that which thing to be used for the Ni square. So I think maybe one of you have made the mistake for the Ni square. So since this one is a gallium arsenide, we know that the intrinsic carrier concentration is 1.8 times 10 to the power 6. And I is 1.8 times 10 to the power 6. Okay, Wong Gasing, are you using this? Tan Xuping, are you using this for the Ni? But both of you get a different answer. Okay, so let's calculate it. Okay, what about the third person? Let's see. Let's say Ng Han Xiang. What do you get for the Ni? Sorry, for the PO. (3.24 times 10 to the power -4). Okay, so let me calculate. Calculator. So this one is a 3.24 times 10 to the power of, sorry, okay, everything, 1.8 times 10 to the power of 6 divided by, sorry, okay, not divided by 0 pula. Okay, 1.8 times 10 to the power of 6, and square the answer. And then you divide it by 10 to the power of 16. 0.000324. Okay? 程序篇 you may want to check answer again. Okay, see if you make any mistake. Okay, then B. For an apply E field of 10 V over Cm, calculate the drift current density, J drift. This thing very simple. Mu Nm plus mu Pp, then multiply by E. So N and P, you already obtained it. So 10 to the power of 16 plus mu P is 3.24 times 10 to the power -4. Then your mu N, you need to obtain from the table. Okay, this one, mu N and mu P is X5000400. So this is a X500. This one is a 400. Then multiply by 1.6 times 10 to the power -19. Then multiply with the E together, which is a 10. Okay, Ng Wei Hong, are you here, Ng Wei Hong? What's the answer for the question B? Question 1B. J equals to 120 A per cm square. Okay, the rest of you, do you get the same answer? Lim Yongchuan, do you get the same answer as your friend? Lim Yongchuan, are you here? You get 136. Why you all answer all different one? And then Ko Bun Kyung, are you here, Ko Bun Kyung? 136 plus 1, 136, 136, 136. Ng Wei Hong, I think you better check the answer. Okay. So I believe the answer should be 136, since majority can get it. Okay, then we do the C. C is very simple. You just need to reverse two things only. ND is 0, NA is 1 multiplied by 16. Okay, so this one, NA 1 multiplied by 16, ND 0. We know that the majority PO will be the reverse one. Okay, so the PO should be, this thing should be two things reverse, right? So this one 10 to the 16, and it should be 3.24 times 10 to the power -4. But when you are going to calculate the J drift, things may be different. Mu P P E. Okay, because right now your NO and PO already reversed. NO is 3.24, PO is this thing. So your mu N and mu P is still the same. So what's the final answer? Let me pick some guy. Lim Chun Wei. Are you here, Lim Chun Wei? For the question 1C. Mr. Lim Chun Wei, can you hear me? What's the answer for the question 1C? Have you done this question? Okay, you get 280 A per cm square. Okay, the rest of you, any plus one. What do you get? Do you agree with your friend's answer? Hu Heng Dong, are you here, Hu Heng Dong? Do you get the same answer as your friend for question 1C? No. But what's your answer? Choose by Lim Chun Wei. 6.4. Any other remaining thing? Okay. Okay. So plus 1 is on the 6.4, not the 280. So Lim Chun Wei, check answer, I think. Not Li Zhong Wei, Lim Chun Wei. Okay, LCW. Okay, so let's go to the next question. N-type silicon crystal having the cross-sectional A 0.001 cm square, length 10 to the power 3 cm. What? Have what? T 300K. And then your I is 100 MA. Okay, first thing, very basic. What's your R? Resistance. V equals to IR. Wang Chongyi, what's the answer for question 2? 2A. Wang Chongyi, are you here, Wang Chongyi? 100. Okay, so any other objection? So this is 10 times 100 times 10 to the negative 3 on here. Okay, nothing much. Okay, then let's proceed to B. The required conductivity. How do we calculate the conductivity from here? So in order for you to do this question, you need to see the lecture 6. Okay, it's somewhere around here, this part. Okay, conductivity. Whenever we do the conductivity, we know that this is the formula that we're going to use. V and I is already there. V, L, conductivity, A, and I. All you need to do is shift these two areas to places only. Sorry. L, V, A, and I. Okay, so let's pick some guy to answer this. Yong Wing Liang, what's the answer for the question B? Zero by 01. The rest of you, do you get the same answer as your friend? 0 by 01. In cm, yes. Okay, what about the rest? So everything calculated here should be in cm. Same. Any other objection? Okay, so I believe the answer should be 0.01. Density of donor atom to be added to achieve to this conductivity. So this thing, if you want to solve this, you need to equal this 0.01 equals to E mu n n. Okay. Then you assume that there is a nothing because it's an n type. So we assume that the P will be equal to 0, something like this. Okay. No. We assume that the ND will be NA will be equal to 0. Okay, we assume in this way. And then we just directly use this first. Okay, to calculate our N. Then we can equal your N is more or less equals to the ND approximation. So in order for you to do this, you just need to use 0.01 divided by E divided by the mu N. So for the mu N for the silicon, which is 1350, if I'm not mistaken. 1350. We make this assumption. Okay? So what's the answer? Okay, for this question, C. Lao Lok Jing. Are you here, Lao Lok Jing? Okay, you get 4.63 times 10 to the power 13. The rest of you, do you get the same answer? Yep, this one is CM. Okay. What about the rest of you? Ong Mei Ling, do you get the same answer, Ong Mei Ling? Okay. So let's see the last part for this question. The concentration of acceptor to be added to form the compensated p-type semiconductor with conductivity given from the part B if the initial concentration of the ND is 1 times 10 to the power 15. Okay, so let's see what are we going to do with this question. So he asked to calculate Na. Okay. Na to form the concentrated this thing is the Nd is this thing. So we believe we experienced quite many times, especially in the test also. So this one you can refer to this. Na minus Nd will be equals to on MV, sorry. So this thing should be, okay, let me rewrite everything first, I'll be messy. What is it asking about? Yeah, let me get back. Maybe if the initial concentration is Nd, so we are using the Na minus Nd. Okay, equals to so this thing is a EF minus EV KT. So this one is a NV and A minus ND. We are supposed to do it this way. Okay, so and then let's get back to the question. Just now the conductivity is given here, E mu N M plus mu P and P. And then we assume that the N is already here. Yeah, something is missing, I think. Any of you able to solve this? Okay, this one is given, this one is given, this one here, and we assume that the ND. Okay, let me think about it. So NO is already almost equal to the NT. And then, interesting. Anyone in favor of this? Yeah, I know. Okay, this question I think I need to carry first. Okay. We go to the question 3 first. We don't do the question 2D first. Okay. I think this thing is a little bit confusing for this question. We do the question C first. Okay. Okay. A silicon semiconductor resistor is in the shape of the rectangular box. And this thing is A is equals to 100 mu m square length is 0.1 cm. Then this one is a dot with the concentration of the gallium arsenide atom. And then this one is the bias of the 5V is across the silicon. And then calculate let T equal to 300. 5 volt is given. So this one, we assume this one is either ND or NA. We still don't know yet. 16 cm minus Q. Then calculate the current in the resistor. Okay, this one using the V equals to the IR. And then we can also use the same formula just now. Then V equals to the I is given, L is given, and then the A is given. Okay, this one arsenide atom. Since it didn't mention whether this is an ND or the NA, we just assume this one as an ND first. Okay, ND equals to 5 times 10 to the power 16. Okay, and then we try to calculate this one, the conductivity, and then we put inside here, and then we will calculate the I. So what's the answer for 3A? On mailing, do you get anything? What is 3A? What is it? Yep, 1/4. Do you get the same answer? 5/4 ampere. The rest of you? Wong Ga-sing, what do you get for this? For the 3A? Wong Ga-sing, are you here? 5/4 times 10 to the power -4. With -4 or before? -6. How come you guys got so many different answers? Yong Qie, your answer is? Everything must be in cm, cm. L in cm, A in cm. Okay? Your L, since in the question it listed, your A, since in the question it listed that A is in the mu m squared. So you need to convert it back to the cm square also. Okay? So any other answer? So 5/4 minus, no wonder. Okay, you must use cm, cannot use m. So Yong Qie, you're using cm or m? So this 5/4 is in cm. Your area also in cm. M. This one is cm. Have you changed to cm? Okay, then I think should be the valid one because the tricky there is there. 1084. Okay. Okay, then the second question asks, repeat the part A if the length is reduced to 0.01. Okay. So we use the same formula, then we get a different A. Sorry, different I. We change the length. Length drop, then I, what's the answer? Let's see. Too easy, are you here too easy? What's the answer for the B? $54. Do you guys get the same answer? Got any plus one? Wong Gasing, what about you? So your friend get for 54 ampere for B. Five by 4 times 10 to the power negative 3. So this is Wong Gasing, 5 by 4 times 10 to the power negative 3. So how many of you get 54A? How many of you get this one? A and B. Which one do you get? A or B? Everyone take an answer. B. Okay. Simple and direct should be B. Okay. So too easy. Check your answer again. So the last one, I think we didn't cover it because it covers average drift velocity. Normally we are calculating a drift current density, but not the velocity. By the way, the velocity actually we didn't cover that, so you don't have to worry about the 3C. Okay. So let's go to question 4. Consider a semi-silicon that is doped with the ND equals to 1 times 10 to the power 14 and A equals 0. Apply E equals to 100. Mu N 1000, mu P 0. Then your NC, NV, and EG is given here. Okay, calculate the electric current density. This one is obviously the drift current density, no doubt. Okay, so this one, NC and NV is given here. EG is also given here. So in this case, you need to calculate your NC, NV, ESP, negative EG, or KT to get your NI square. Okay, so after calculating the NI square, in order for you to calculate the drift current density, you need to use the ND and the NA information for you. So we know that the ND is more than the NA, no doubt. NO will be equals to ND minus NA divided by 2 plus ND minus NA divided by 2 square plus NI square, where your NI square is obtained from here. Then same thing, NI square divided by the NO, you get a PO. This is how we do it. So after calculating all these things, then you only put back the formula E mu N plus mu P multiplied by E. E is a constant, mu N is a 1000 as given, mu P you directly ignore that because it's 0. Okay, so all you need is to calculate the mu N only. So this is how you calculate the A. So what's the answer? Let me pick some guys to answer this. Kwai Yihang. Are you here, Kwai Yihang? What's the answer for this 4A? One point six A. The rest of you, do you get the same answer? How many of you get 1/6A? Plus one. Okay. All right. Okay. So let's go to the next question. So at what temperature will this current density, I think what we're saying here, increase by 5%, which means that, okay, your earlier 1.6 will be multiplied by 1.05 divided by 1.6 multiplied by 1.05. Let's say equals to, let's say S value. S value will be equals to E mu n multiplied by the E, because the mu P will be equals to 0. Okay? Then your E, just divide mu n, divide E, divide, so you get your n. And then your n will be equals to the nd minus the na divided by 2 plus nd minus na divided by 2 plus ni squared, where your temperature changes will be somewhere around here. Okay? Your Ni will be equals to the Nc Mv Esp negative Vg over Kt. And then your Nc or Mv will be changing the T accordingly. Okay, in order for us to do this, we normally need to use the, let's say, the plotting graph in order for us to do the thing. Okay, so it's unwise for you to do everything by the one calculation there. So normally we will put everything inside the computer, then help us to plot the graph. Some other graph is like this. Then we see in what temperature it will give us the value of, let's say, the 1.6 times 1.05 value. Okay, in this case. So I will not advise you to calculate one by one. Okay, in this case. So let's go to question 6 first. Question 6 one is very simple, I would say. Pre-scattering process. Okay, mu1, 2000, mu2, 150, mu3, 500.
EY 大不成
Sorry? Yes? Anyone speaking here just now? Somebody is talking. May I know who is talking? Okay, let's continue. And then this one, 1 over mu will be equals to 1 over 2000 plus 1 over 1500 plus 1 over 500. Okay? So you just calculate accordingly. And that's what's the answer for mu? $315.09. The rest of you, do you get the same answer? Or can sing what's the answer? Okay. Then let's see who else I haven't called. Long Yao Ting was the answer. Long Yao Ting, are you here, Long Yao Ting? Don't know how to do this part. Okay, fair enough. Let's see who else. Lou Tiong Lei, what's the answer for this part? Do you get the same answer as your friend? Okay. So let's proceed to question 6 and question 7. Last two questions. So this one. S is 0, EF minus EFI will be equal to 0.4 EV. Then where S is 10, negative 3, EF minus EFI is equal to 0.15 EV. Write the expression for the electron concentration over the thing. So we assume that the electron concentration is NO and Ni exponential EF minus EFI over KT. So we don't know this, but we know this. Okay, so Ni will be exponential. One is 0.4 over KT, minus Ni exponential, then 0.5 over kT. Okay, so this is the expression. And then if the Dn is 25, calculate the electron fusion. Oh, this one is silicon. So Ni, just replace the value inside there. Okay, 1.5. So this was a Ni, intrinsic 1.5 times 10 to the power 10. So this is a 1.5 times 10 to the power 10. And then he didn't state about the what? The temperature carry. We assume that this is a 300 K in this case. Okay, so difference 0.0259, 0.0259. We assume that. Okay, and then if the electron diffusion coefficient is Dn equals to 25, calculate the electron diffusion current density at the T equals 0, then this one the S equal to 5 times 10 to the power negative 4. Then to do this case, you can refer to this one, this formula. Okay, E dn over ds. Okay, like this only. So you can do it like, for example, suppose you are going to have the changes between the this and this, then you just need to use this minus this, then divided by the ds, then go into this. Okay, but this time I won't go deep because we have one last question and it's there 8 minutes only. So we directly jump to the question 7, which is more important one. Okay, so let's say the menu is start with the donor atom 15T100K. Dimension of whole device T equals to 5 times 10 to the power negative 3, W 2 times 10 to the power negative 2, L 10 to the power negative 1, mu S 250, mu A is. So applied voltage Vs 100 M, then magnetic flux 5 times 10 to the power negative 2. Calculate the whole voltage, whole field, and carrier mobility. Okay, so to do this, we need to use the right formula. Okay, we know that this one is an ND, obviously. So note that this is the N voltage. This is a majority is N, where we are notified here already. And then in this case, we assume that the NO will be equals to the ND, which will be equals to the 5 times 10 to the power 15. Okay, then we just need to use the formula to help us to calculate the answer that we want, which is this: N equals to the IS BZ ED VH. So for the question 1A, he asks us to calculate the VH. IS given, BZ given, E given, D also given, then N is given. Remember, convert everything into the meter before you do it. So what's the answer for this 1A? Who else I haven't called? Teo Ho. What's the answer for the last question? 7. 7A, B, and C. Just tell me all the answer at one shot. Whole voltage. Okay, what do you get for the whole voltage? What is this answer? What is this two? Can you tell me more detail? Otherwise, we cannot get you. Teo Ho? Okay. Then And then? Okay, so the rest of you, do you get the same answer as your friend? So your friend get a VH equals to 1 times 10 to the power of -6 watt. So E is 5 times 10 to the power -3. P is 1.5625 times 10 to the power 24. Wong Gasing, what do you get for these three items? Mr. Wong Gasing? You didn't convert it to M, so I assume your answer will not be correct. Brenda, are you here, Brenda? Yes. What do you get for these three answers? Do you get the same value as your friend? Not same. What do you get for your answer? Okay. Your V will get -312.75 watt. Then your E. By the way, to calculate this E, the Hall field, you need to use the formula of this one. Okay. ESW 0.5. Then your E. Okay, -1.53563 times 10 to the power of 6. Then the last one, the mobility, mu P, mu N, not mu P. 3.125 times 10 to the power 5. Okay, Eng Han Xiang, do you get the same answer as Brenda? Eng Han Xiang, are you here, Eng Han Xiang? You get 3.125 times 10 to the negative 4. Which one? Mu N. Okay, since everyone of you get a different answer, different version, I will calculate and get back to you in the next Monday. Okay, to give you a final answer directly instead of wasting our time here. Okay, so we have almost the time. So I think that's all for today. Thank you very much. Any question so far? If not, then I think we can dismiss the class for today. Thank you very much and have a nice weekend. Okay, bye everyone.